This is the ECE 423 Cadence Tutorial, Department of Electrical and Computer Engineering, Southern Illinois University at Carbondale. Chapter 4, Layout and Post-Layout Simulation. First, before doing a layout, you need to have everything laid out, your blueprint, your sizing, and everything in place. We will assume that has already been done, and we're going to go ahead and create our layout based on, for our schematic that we created in Chapter 3. You need to go to the Library Manager window, and we will do a new cell view. And we will do for the inverter cell, and our view type will be layout, and press OK. And notice we have this L, which basically lists all the different types of minerals and polys and everything that we'll be using for the layout. And first thing we need to do is we need to go and set up our options. Very important. Display options. You need to set X snap spacing to 0.005 and Y snap spacing to 0.005. Press OK. Then we need to make sure that the gravity is turned off. So go to Options, Edit Editor. And gravity on should be unchecked. Press OK. And let's go to Options and DRD Edit. And we'll turn interactive mode to notify. And violation edges we'll check. And press OK. This will give us a little visual indicator of later on, whenever we're moving things around, about the spacing that is required between different objects and of the sizing of the individual objects themselves. So now that we have all of our options set up, we can start creating our layout. First thing to do is create an NMOS. So we will create an instance, and we will browse, and under the GPDK 045 directory, we will choose the NMOS 1V, and we want the layout view. And then close and hide and place on your layout. Click and escape to stop. And we'll zoom in a little bit here, so we'll take the right mouse and we'll drag it across this area to get a zoomed in area of this here. And we'll do one more time here. A little bigger area. Okay. Now we need to add a PMOS 1V. Of type layout. We'll place it directly above the NMOS. And now we need to create two vias. We create via, and we will call the first one, we will choose the via definition of M1 P implant. And hide, and we'll place it directly below our NMOS 1V. And next we will create the second V. It is of type M1 N implant. And this will go directly above our PMOS 1V. Okay, now we need to select all of the blocks, Control A, and we need to flatten them. So go to Edit, Hierarchy, and choose Flatten. And we want to choose the following options. We need to, for flatten mode, we want displayed levels. We want to click flatten P cells, flatten vias, and preserve pin geometries, and press OK. Now we need to connect the drain of the NMOS and the PMOS. So what I will do is I will zoom in on the PMOS first, and I'm going to extend the metal 1 layer here. By stretching it. First, let me move it out of the way. Now I will stretch it. To go from the PMOS with the mouse. And I can delete the existing one here. And I'll move this section over so that our contact will be in line. Next thing, we need to connect the polys of both of them together, and it creates all little squares here, but I'm going to just delete all the squares except for one, and I'm going to use the same rectangle along each one. And similarly, stretch the metal 2 as well, so that we only have one metal 2. Notice how the DRD edit options give us little visual pointers onto how big we need to move things. Let's stretch our poly. Stretch the poly. And we'll remove all these excess polys here as well. And we will create a shared metal 2 across the endmost. And stretch poly. Next, we need to create a contact. So what we need to do is we need to go over to the LSW window, and we will pick the contact draw, and we will create a shape, a rectangle, and we will we know it needs to be 0.06 by 0.06. And our DDRDS show our proper range is in place. We can also use the ruler to make sure to double check if we want. So we create a ruler, tools, create ruler, and then click, and then stretch the ruler as far as you need it to go. And we'll measure the length and the width. And we that our contact is 0.6 by 0.06. So once we're done with them, we can remove our rulers. And we will place our contact. Moving it. And we need to create a little poly around the contact. So we'll create another shape using the poly draw, another rectangle, then we need to create a metal 1, rectangle, for contact. Similarly, we need to create a via 2 for NMOS and PMOS. So first we need to stretch 1. Stretch our metal 1 and join it with our via that we created earlier. And once again, we'll remove all excess ones. And join these together. And we'll align our objects. Stretched out. These a little bit. We will do the same for the mouse. For the PMOS. And we will stretch out. These areas as well. And we will stretch out this area. To enclose, to cover both the PMOS 1 V and our VIA area. Next, we need to add pins. So first we will add a pin, create pin, and we will create an input pin called in. Its direction will be input, and our type needs to be metal 1 pin. So we will select metal 1 pin from the LSW window. And create a pin, name in, rectangle, high, and we will place it on our layout. Next, we need to create an output pin, and the output pin was also of type metal 1 pin. We'll call it out. It's type output. It'll hide, and then we'll put the pin directly on our metal 1, connecting the drains of both transistors. Click, drag, and click to set it. Now we need to create a metal 2 pins for VDD and VSS. So we need to pick metal 2 pin on our LSW window. And we will create pin, VDD, type input output, hide. Then we'll click. So first we need to add a V1 draw to create our via contact first. So we'll choose via one draw, and we'll create a rectangle, and via ones need to be 0.07 by 0.07. CRD or D edit and in action here. Click, and we can verify with our ruler that the sizing is proper. And we see the height is good, and our width is good. So we know our VO1 is of proper size. So move it out of the way, and we'll delete our rulers since we no longer need them. I'm going to make one more copy. Via once, we'll need one down below as well. We'll place our VO1 on our middle 2. And we'll place our second one down below the endmost. Now we need to create a metal 1 to cross from our contact via 1 across our metal 2. So we will need to go create a metal 1 draw. Create rectangle. And we'll do the same thing down below. We'll just gonna copy this guy. So now we will extend our metal 2, pick a metal 2 draw, and we'll create another one down below. And now we can create a couple of metal 2 pins or VDD and VS. Just go over to the LSW window. Choose metal 2 pin, and we'll create a pin, type VDD, input output, hide, click, move the cursor and click again. And similarly, do the same thing to create a pin for VSS. Type input output. And now we'll save this. And now we have created our initial layout for our inverter.